So it's a lightning talk, so I thought I'd keep the bio brief. I'm Jack, I work for Prospect Path. I'm also one of the organisers of PHP Northeast. So continuous integration, quite popular nowadays to have some kind of continuous integration process, but a lot of the time that process is quite simple. Maybe it's just running your unit tests and then handling deployment for continuous deployment of your application. There are a couple of ways people tend to do this. I think most popular, people will either have a Jenkins setup that they've done themselves, or use some kind of cloud service for their CI. I use CodeShip, and that's what I'm going to focus on mostly in this talk. So cloud-based services, very simple to get going with, but they do have certain limitations. You have less freedom to install your own software and run other software alongside the things that come out of the box. So there are different types of security tests that you might be able to automate. Your unit tests probably help to ensure some level of security of your application by just checking that authentication is actually enforced, that users don't access things they shouldn't be able to. If you find a security vulnerability, obviously it's a good idea to add additional tests to check that it doesn't creep back in at a future point. Obviously, having tests that ensure the entirety of your authentication process works and is applied all the time is important. So having a full integration test across all of the technology is important. But there are other tests that you can add that aren't in this kind of self-written unit test or the standard kind of integration and functional testing that you might already have. If your system uses a lot of dependencies, you can add tests that automatically check whether there are any vulnerabilities in the dependencies you're using. You can also use automated testing to look for bad practices in your code, which could lead to security issues. And along similar lines to that, you can test for where any known vulnerabilities have been put into your code. So adding automated security testing is useful, but there are some limitations to it. I wouldn't recommend relying on automated security testing as the kind of first line of defense for your application. Trying to follow good practices and ensure those issues don't creep into your code in the first place is the best way to handle things. And this is a kind of secondary way to try and pick up on anything you've missed during your normal development. So yeah, you should be reviewing code and using the best industry standards for your authentication and other key areas of your system. And then ideally, although this isn't a possibility for a lot of smaller companies, if you can have a penetration test, that's obviously a really good way to find security vulnerabilities as well. But there are some benefits to using automated security testing as part of your CI process. There's very little you have to do a lot of the time. There might be some configuration, but there are certain tools that you can just drop in and they'll identify issues with very little effort. You're not going to slip out of the habit of using these tools if they're part of the processes that you're following and are automatically employed every time you push some code to the server. And the tests are fast to run, and the overall cost to adding them to your processes is very little. So if, say, penetration testing isn't something you could easily have at the moment, automated testing could be a good option. So you could be testing a modern-day PHP application. Something like Laravel has fairly good practices for authentication and things like that built in. But modern PHP applications do tend to have a lot of dependencies. So looking for vulnerabilities in dependencies could be an important thing. If you have a legacy application, it might be more important to look through large amounts of code to check whether bad practices have been followed or any known vulnerabilities occur in the code. And if you have architecture as code, you might also want to scan that and look for any known issues in your server configuration if that's coupled to your code. So there are two main types of security tests you can run. Black box security testing is where the test has no access to your code. It's simply looking at the server or the version of your application and trying to find vulnerabilities. Black box testing can often find cross-site scripting issues and SQL injections by running known attacks against your server. And black box testing often uses similar techniques to the bots that are just scanning applications on the internet to look for these already known issues. Most of the other security tests that you can automate rely on analysing your code base and looking for issues that way. So they check the code and its dependencies for issues, look for known vulnerabilities, and check practices of your code. And naturally, when you're using a kind of CI tool, the code analysis style of testing fits better. You're generally analysing your code to look for issues, although it is possible to do some black box testing. Yeah, so you can also look for SQL attacks using code analysis. PHP Security Checker is a Symfony library that you can use to check your Composer dependencies for any known vulnerabilities. It can be installed via Composer, or you can just pull it down separately. If you didn't want any of these additional checks to touch your repo for some reason, you could just pull it in directly to the CI server. And it checks a list of known vulnerabilities to see if any of your packages have those issues. And the script that runs exits with a non-zero status code, so it's really easy to just drop into a continuous integration system and your build will fail as soon as there's an issue. SNCC, which my brain always tries to autocorrect to sync when I read it, is a similar tool to the Symfony one, but it's cloud-based. So it also scans your dependencies for vulnerabilities. It'll work across more languages, so the Symfony tool just scans Composer files. This will look for PHP and JavaScript and some other languages as well. It'll actually advise you on the upgrade that you should make to the package to fix the vulnerability. And it can even create pull requests to kind of put that update into your code for you. So that's free for 200 tests a month with some limitations to what you can do. It'll produce reports of your dependencies and things that aren't available in the free version. So PHP Code Sniffer is a tool you can use to analyze your code for kind of bad practices. And there's a library that's built on top of this that specifically tries to find security issues in your code. So, yeah, normally PHP Code Sniffer looks for code style rules and analyzes those, but in this case it's looking for vulnerabilities. You can pull it in with Composer. And again, if there are any issues, it exits with a non-zero exit code, so you can just drop that straight into your continuous integration setup. And you can choose to ignore any files via comments or adding a list to the command that you run. SonarQube is a tool which is a bit more involved to set up. It needs its own server that it runs that has a web interface you can log into, and a database. And this is another, there are free and paid versions of it. It can analyze a lot of different languages, one of them is PHP. And this looks for vulnerabilities in code. It produces kind of reports on the quality of your code, but it will detect security issues. And if you're using Jenkins or another popular continuous integration tool, there are libraries built for it to integrate. So this is a rough outline of how you would integrate SonarQube into a CI build. It has a library that runs on Jenkins or CodeShip or whatever, and it produces an analysis which it pushes off to the SonarQube instance, and then you can either view the results of that analysis by logging into their web interface, or it can push that information via a webhook so that you can block deployment to production, for example. And then, yeah, there are a couple of other solutions that only have paid versions, SourceClear and RIPS or RIPS. They both do the similar vulnerability scanning to SonarQube. They both make claims about having more kind of rich databases of vulnerabilities. Whether or not that's actually the case, I'm not sure. So I'm going to just give an example of how you can drop a couple of those tools in to your CI build really quickly. It'll probably take you 5 minutes or so just to add these in, and then you can be checking for issues with dependencies in your code and known vulnerabilities in your code. So you just add to your composer PHP code sniffer and the security audit library. In your build, if you just pull down the Symfony dependency checker and the security audit tool as well, and then when you're running your actual commands, run the Symfony security checker and the PHP code sniffer, specifying that set of rules for looking for security vulnerabilities. And then this is a, not very clear on this projector, example of what you'd get on CodeShip if you had an unsafe dependency in your code. So essentially your build would fail and it tells you which dependency is unsafe. And a similar example showing a known vulnerability in the code itself. Thank you.